So a lot of you in your high school geometry or trigonometry career, or even further on, like in an AP course, have probably at some point been required to use the trigonometric identity of cosine squared plus sine squared equals 1. But do you know where that actually comes from? Well, if we construct an arbitrary triangle here with base x, height y, and hypotenuse r, with some angle in between there, then, okay, let's begin by describing what we know about it. So x squared plus y squared equals r squared. This is, of course, just very well known Pythagorean theorem. It turns out that we can get to this point if we just multiply the whole thing by 1 over r squared, because that's going to get rid of the r squared, and r squared over r squared is going to get us to 1. So let's go ahead and do that. So okay, so now what's this going to give us? Well, x squared over r squared plus y squared over r squared equals 1. So, okay, let's take the square out of both of the pieces. So we have x over r squared plus y over r squared equals 1. Well, we commonly know these to be the ratios cosine and sine, because if we take x over r in this case, well, that's just going to be our adjacent over hypotenuse, which we know to be cosine of the angle, and y over r, that's just our opposite over hypotenuse, which is going to be the other one here that we're interested in. So if we want to substitute this back in, then we can go ahead and do that. So put the cosine and the sine in like this, and now someone who might not be aware of this might be like, okay, how can we get this to this form with the square on the inside? But actually, it's commonplace in mathematical notation to say that these are equivalent ways of being able to describe the same thing. So basically, cosine of the angle squared equals cosine squared of the angle. These are equivalent. It's a way of describing the same calculation. So likewise, sine of the angle squared equals sine squared of the angle. But someone might say, well, what if I want to square the angle or something like this? Well, then you would have to go ahead and apply that directly to the angle on the inside like that. But we don't care about that here. So let's go ahead and put this in like this. And that's where this comes from. Also, another important thing to note is that what if we care about describing cosine or sine in terms of the other one? Because sometimes that might be important. So, okay, we can actually just do this pretty simply as solving for the other one here. So we can say cosine squared theta, and then we can put this on the other side, equals 1 minus sine squared theta, and then we can square root both sides here. So cosine of the angle turns out can be described as the square root of 1 minus sine squared of the angle. And if we want to figure out what sine is in terms of cosine, that can also be important. So let's go ahead and put the cosine squared over on that side. Okay, so 1 minus cosine squared of the angle. So after we take the square root of both sides there, we're going to get that the sine of the angle can also be described as the square root of 1 minus cosine squared. So this is just a little bit about where this particular identity comes from. There are lots of others that I could make a separate video on, but until next time, stay tuned for more of Joe Shows You How.